never dreamed of seeing the sky dance with vibrant, shimmering lights. That incredible natural wonder is the Aurora, and today, we're going on a journey to uncover all its secrets.
From the vastness of space to our own atmosphere, we'll find out exactly how these celestial ballets are born. So get comfortable and let's head to the poles. It all begins with our star, the sun. The sun is constantly sending out a stream of charged particles across the solar system, a phenomenon we call the solar wind. Think of it as a constant cosmic breeze. But sometimes the sun gets a little more energetic.
During events like solar storms or coronal mass ejections, it unleashes a massive, super fast burst of these particles, hurtling them through space.
And some of them head straight for Earth. Now, you might be thinking, a storm of particles from the sun. That sounds dangerous.
And it would be, if not for Earth's amazing defense system, our magnetosphere.
This is a giant magnetic bubble surrounding our planet, created by the molten iron core deep within. It acts like a shield, deflecting the vast majority of the solar wind away from us.
We owe our very existence to this invisible force field.
Without it, the solar wind would have stripped away our atmosphere billions of years ago.
But this shield isn't perfect! While most particles are deflected, some get trapped by the magnetic field lines. Imagine the Earth as a giant bar magnet with a north and a south pole. The magnetic field lines loop out from the south pole and curve back into the north pole.
The trapped solar particles are forced to spiral along these magnetic highways, and they get funneled down towards the Earth's polar regions.
This is why auroras are almost exclusively seen near the north and south poles. They are a direct visual representation of our planet's magnetic field in action. So we have these energetic particles from the sun, guided by magnetism, racing towards the poles. What happens next is where the real magic begins. As they plunge into the upper layers of our atmosphere, they start a cosmic game of pinball. Our atmosphere, especially at high altitudes, is made up of different gases, primarily nitrogen and oxygen.
The incoming solar particles, traveling at incredible speeds, slam into these gas atoms and molecules. This collision isn't destructive.
It's an energy transfer! When a solar particle hits an oxygen or nitrogen atom, it transfers some of its energy to that atom, knocking its electrons into a higher, more energetic state. We call this an excited state. But atoms don't like to stay excited for long. It's an unstable condition. To return to their normal, relaxed state, they have to release that extra energy. And they do this by emitting a tiny particle of light called a photon.
Now, imagine this happening not just with one atom, but with billions upon billions of them all at once.
Each collision, each excited atom, and each released photon contributes to a massive collective glow. This is the aura. It's not a reflection, and it's not light from the sun. It's light being created right there in our own upper atmosphere, a breathtaking display powered by the sun and shaped by the Earth. It's like our planet has its very own set of neon signs switched on by a solar storm. One of the most captivating things about the Aurora is its stunning array of colors. You might see ethereal greens, deep reds, and sometimes even hints of blue or violet.
Why the variety?
It all comes down to two key factors: which gas is being hit and how high up in the atmosphere the collision is happening. The most common color you'll see in an aurora is a brilliant, glowing green. This light is produced when solar particles collide with oxygen atoms at lower altitudes, around 100 to 200 kilometers, or about 60 to 120 miles above the ground. Our eyes are very sensitive to this shade of green, which is why it often appears as the brightest and most dominant color in a display. But if you look higher up in the sky, especially during a very strong aurora, you might see a beautiful, deep red glow. This is also caused by oxygen, but these collisions are happening at much higher altitudes, above 200 kilometers. Up there, the atmosphere is much thinner. The oxygen atoms have more time to release their energy, and when they do, they emit red photons. Because it's higher up and the light is fainter. Red is often only visible during periods of intense solar activity. So what about the blues and purples? These rarer colors come from nitrogen. When solar particles strike nitrogen molecules, they can emit blue light. If the particles hit nitrogen at even lower altitudes, they can create a purplish or pinkish violet fringe, often seen at the bottom edge of the main auroral curtain. So when you look at a multicolored aurora, you're essentially seeing a beautiful, layered map of our atmosphere's composition, painted by the solar wind.
So, where on earth do you need to go to witness this spectacular light show? As we've learned, the aurora is concentrated in ovals around the Earth's magnetic poles.
In the northern hemisphere, this phenomenon is famously known as the Aurora Borealis, or the Northern Lights.
The prime viewing locations are in a region called the auroral zone. This includes places like Alaska in the United States, large parts of Canada, especially the Yukon, Northwest Territories, and Nunavut, Greenland, Iceland, and the northern parts of Norway, Sweden, and Finland, an area often called Lapland. Northern Russia also offers incredible views.
If you want to see the northern lights, these are your go-to destinations.
Down in the southern hemisphere, the aurora has a different name, the Aurora Australis, or the Southern Lights. Because its auroral zone is centered over Antarctica, it's much harder for most people to see.
The best chances for viewing it from populated land are in the southern parts of Australia, particularly the island of Tasmania, and in New Zealand, especially on the South Island.
During extremely powerful solar storms, the auroral ovals can expand, and the lights have been seen from
Much lower latitudes, but these are very rare events.
Now, for the crucial question. When is the best time to see an aurora?
It's a combination of cosmic timing and earthly conditions.
First, it's all tied to the sun's activity, which follows a roughly 11-year cycle.
This cycle has a peak called the solar maximum, when the sun is most active, with more sunspots and solar storms.
Naturally, your chances of seeing a brilliant aurora are highest during and around the solar maximum.
We are currently approaching one now, so the next few years should be fantastic for aurora chasing. On a shorter time scale, the best time to see the aurora is, of course, at night. You need a dark sky. The lights are there during the day, but they are far too faint to be seen against the brightness of the sun.
This is why the winter months are ideal for aurora hunting in the polar regions.
The nights are long, giving you a much larger window of opportunity.
Interestingly, the periods around the spring and autumn equinoxes in March and September often see a spike in auroral activity.
Scientists believe this is due to the way Earth's magnetic field is tilted relative to the solar wind at these times of the year,
allowing more particles to get through. Finally, you need the right local conditions. The number one enemy of the aurora chaser is clouds. You need a clear, cloudless sky. You also want to get as far away from city lights as possible. Light pollution can wash out the fainter details of the aurora.
So heading out into the countryside or a designated dark sky park is your best bet for an unforgettable experience.
So, to recap this cosmic journey,
The sun sends out charged particles in the solar wind.
Earth's magnetic field funnels these particles towards the poles.
They collide with oxygen and nitrogen atoms in our atmosphere, causing them to glow.
This creates the beautiful dancing lights we call the aurora. The color depends on the gas and the altitude of the collision. You can see them in the far north as the aurora borealis and in the far south as the aurora australis. Your best chances on a clear, dark night during a period of high solar activity.
Seeing the aurora is truly a bucket list experience.
It is a powerful reminder of our planet,
Connection to the wider cosmos and the invisible forces that protect and shape our world.
I hope this has inspired you to one day see it for yourself. Thank you so much for joining me on this exploration of the aurora.
If you enjoyed this video and learned something new, please give it a thumbs up, and do you forget to subscribe and hit that notification bell so you won't miss our next adventure.
Until next time, keep looking up.